Alright, we've got some more work to do. We have to prove that true half, so true is precondition, run the code half, x is equal to 2 times y. Okay, so I'll write my goal at the bottom. True half, x is equal to 2 times y. That's our goal. How do we get there? Well, what is half? Half is init followed by loop. So the only way to get there is to do sequencing. So we need to have true init something, and then that same something, loop, and then x is equal to 2y. Okay? Now, doing assignment backwards when you've got a while loop, it's not so easy, right? I mean, it's not an assignment. So what's easier is trying to prove this forward. So we have true, we run init, we need to guess some mid-condition m. I need to guess some condition m, such that this is true with m as a post-condition, and this is true with m as a precondition. So I want to come up with the strongest statement I can, the most useful statement I can here in the post-condition, such that I get a strong precondition. So if init assigns x to be 0 and y to be 0, it looks like all we can really say is that x is 0 and y is 0. So we'll try to prove that. So x equals 0 and y equals 0. And then same again, x equals 0 and y equals 0. So we're going to have to prove these two statements. So I'll do this one first. True init that. So I'll just replace the code. So we have x assigned to be 0, y assigned to be 0. Okay, we do sequencing. So we have true x assigned to be 0, something, y assigned to be 0, x equals 0, and y equals 0. Do assignment backwards. So this is going to be x is equal to 0 and 0 equals 0. And then that's going to be the same up here, x equals 0 and y equals 0. This is true by assignment. Do assignment backwards. So we have x equal to 0 and y equal to 0. X assigned to be 0. Oops, that should be 0 equals 0 here and 0 equals 0 here. So that way these two statements match. Okay, so we have 0 equals 0 and 0 equals 0. Replace and 0 with an x to get that. That's true by assignment. And it's not hard to see this thing is always going to be true. So 0 equals 0 and 0 equals 0 is logically equivalent to true by logic, which means this statement here is true by precondition equivalence. Okay, I'll put in the line numbers afterwards because we have stuff in between. We still got to prove this statement here. This is true by sequencing. So we have to prove x equals 0 and y equals 0, loop x equals 2y. So we'll do that in a separate section. So x equals 0 and y equals 0. And what's loop? Loop is all that stuff. While x less than a, x increase x by 2, increase y by 1. X plus 2, y is assigned to be y plus 1. Actually, I don't need an additional section for this because I can reuse this proof up here. What am I doing? So we can take this statement here, and so if we want to get this, that's going to have a loop in it. That's going to have a while statement in it. How do we get whiles? We have to have p and b. So I don't want this. I want this with b in it as well. So I can freely strengthen the precondition because x equals 2y and b, which is this. B is our loop condition. X less than a implies x is equal to 2y by logic, which means we can precondition strengthen line 5. So if x equals 2y and x is less than a, this code here, which is body, and then post-condition x is equal to 2y by pre-con strengthening. Okay, now how am I going to get from here down to here? I can't immediately. So let's just use the while rule and see what happens. So we're going to get P, x equals 2y, while B, so while B do S, that's going to be loop. And then we get P and not B afterwards. So x equals 2y and not B. So x, it's false to say x is less than A. That's by the while rule. Okay. So how do we get from here down to there? Well, this precondition looks stronger, right? Because if x is equal to 0 and y is equal to 0, surely 0 is equal to 2 times 0, right? So I'll try to squeeze in a logic statement. I'll put a different color so it's more visible. There we go. X equals 0 and y equals 0 implies x is equal to 2y by logic, which means that we can get this line here by precondition strengthening this line here. It's a bit all over the place, but that's okay. So now we can put in the line numbers. I'm just going to continue from above, so I'm going to call this line 6, line 7, this is line 8, this is line 9. Where did this come from? It came from up here, precondition strengthening, we cite the logic and then we cite the code. So we cite lines 8 and lines 5. Okay, line 10 is the while rule applied to 9. Line 11 is precondition equivalence of something. Precondition equivalence of 6 using 7. Yep. And technically there is no precondition equivalence in your sheet. But you can imagine precondition strengthening, precondition weakening can also be used as precondition equivalence because it's just like a more restrictive form of this rule. So precondition equivalence. Assignment, that proves itself. Sequencing, and what did we connect? We connected 11 and 12. 13, that's 13. 14 is logic. 15, precondition strengthening lines 5 with 14. Yep. Because we took this line here and we strengthened the precondition to, I'm actually lying to you, this is loop. So it's actually from line 10, my mistake. So 10 and 5, but then the post condition won't match, right? The post condition is left unchanged. So we're going to have x equals 2y and x, it's false to say x is strictly less than a. So we got that precondition strengthening 10 and 5. 10 and 5. No, the precondition changed, so it's x equals 10 and 14. Jesus, David, come on. So x equals 0 and y equals 0 implies x equals 2y. So replace the weaker thing here with the stronger thing here. 10, 15. Goodness me. 14 is the logic statement I'm using. And 10 is the line that I'm citing. There we go. Now, there's got to be a step in between here because I have to weaken this post condition. So we're going to have x equals 2y, and it's false to say x is strictly less than a, implies x is equal to 2y by logic, and then we finally get what we want. So line 17 is precondition x is equal to 0 and y is equal to 0, which is so true actually. Did we not hot swap that out? Oh, one step at a time, we've got to sequence the two parts together. So x equals 0 and y equals 0, loop x equals 2y by post condition weakening. Lines 15, 16. and we combine this line here with line 13, which was true init x is equal to 0 and y is equal to 0. So then we get true half x is equal to 2y. Sequencing 13, 17. It's beyond me how that's supposed to all fit in this little box. I think I'll write this all up again nice and neatly, so when I upload this online, you can actually read it.